Welcome to This Explainer. Today we're tackling something I know a lot of you have been trying to perfect, creating the ultimate, borderless battle station. We're going to look at how to take a completely fragmented desk space and merge it into one seamless physical workspace. Whether you're jumping from Windows to Windows or Windows to Linux, we're going to break down how to use a free KVM tool to seamlessly control multiple desktops with zero limits, all from a single setup.
Okay, let's dive right into a universal pain point here. You've got your main Windows productivity laptop, maybe an older Linux rig handling background tasks, and your smartphone sitting right there. But to interact with them, you're constantly juggling 3 different keyboards and mice. Come on, we've all been there, right? You type out a whole sentence before realizing your hands are literally on the wrong keyboard. It's cluttered, it's frustrating, and it just completely wrecks your workflow.
So to fix this, we need a software KVM. Basically, think of it as a virtual switch that creates an invisible bridge over your network. This lets a single physical mouse and keyboard control multiple separate computers completely seamlessly. And our primary tool for this? A totally free open-source program called Barrier. No borders, no messy hardware switches, just smooth control across your entire setup.
And the initial setup is actually shockingly simple. It's a one-and-done deal. First, you install the Barrier server on your main machine. In our blueprint here, that's a Windows 10 LTSC laptop. Because it's the server, its physical keyboard and mouse are the ones that will control the whole desk. Second, install the Barrier client on your secondary machine like a Linux Mint desktop. We're using XFCE here because it natively uses the X11 display server, which Barrier absolutely loves. And third, you just link them together using their IP address.
But there is a catch with this kind of setup. You might have experienced this. You're dragging your mouse across screens and suddenly, bam! It hits an invisible brick wall at the edge of your monitor. Why? Because standard home Wi-Fi routers use dynamic IPs, meaning your computer's internal address changes. The exact moment that IP address shifts, Barrier loses track of the other screen. The connection drops and you're stuck.
So, how do we fix this permanently so you never have to think about it again? Well, we bring in a superpower. Notice the difference here between standard Wi-Fi dropping connections and the secure Tailscale mesh. Tailscale acts like this magical VIP walkie-talkie channel for your devices. Instead of relying on your routers constantly changing numbers, Tailscale gives your machines permanent static IP addresses. You plug those permanent IPs into Barrier once, and that connection locks in forever.
Section 1. The magic of AutoConnect. Now here's where this gets incredibly cool. Once you establish that static network, your setup becomes completely autonomous. See, Barrier itself can't wake a sleeping computer natively, but with those permanent Tailscale IPs, the AutoConnect sequence is a total breeze. You just send a quick wake on LAN packet from your Windows laptop, and your sleeping Linux desktop wakes up instantly over the mesh. And the very second that device comes online again, Barrier reads that static IP, and boom, your mouse and keyboard link silently in the background. It AutoConnects without you doing a thing.
Section 2. Adding mobile to the mix.
Okay, let's see how this builds when we drop an Android smartphone right into the center of the workstation. Picture your desk right now. On your left is your Windows laptop acting as the server. On the far right is your Linux monitor, and smacked right down in the middle is your Android phone. The goal here is to slide your cursor seamlessly from the laptop, straight across the phone's touchscreen, and right onto the Linux monitor on the other side.
Now, the official Barrier project doesn't actually have a native Android app, but that's not a problem because that's exactly where InputLeaf comes in. It's an awesome open-source Android client built specifically to speak the Barrier network protocol. By running InputLeaf on your phone, your mouse cursor jumps straight onto the touchscreen. This means you can literally scroll through feeds or type out text messages on your phone using your main mechanical desk keyboard. Actually, if you want an alternative that guarantees absolutely zero Wi-Fi latency, you can bypass running Barrier on your phone altogether. Instead, you use SCRCY, which stands for Screen Copy. While your phone is plugged into your laptop with a USB-C cable, SCRCY opens your live phone screen as a super-fast, borderless window right on your Windows desktop. You just position that window on the right edge of your screen. So you slide your mouse to the right to control your phone natively, and pushing it just a few pixels further right kicks Barrier into action, jumping your mouse straight over to your physical Linux monitor. It's incredibly fluid.
Section 3. The KVM reality check.
All right, a quick warning here because even the best software has hard physical limits. Pay close attention to this. Do not use Barrier for 3D aiming in games. Software KVMs will completely break your input if you launch a first-person shooter. Games use relative, raw mouse input to look around in 3D space. If you try to aim using a mouse that's being piped over a network through Barrier, your camera is going to spin out wildly.
For gaming, you absolutely must plug your mouse directly into that specific machine.
And the other major reality check we need to talk about is file transfers. The biggest misconception out there is that you can just click a file on your Android phone, drag it across the screen border, and drop it onto your Linux desktop using Barrier. Yeah, because of heavily sandboxed file systems, that is basically impossible over a software KVM. So instead, you rely on these bulletproof tools. Use Local Send for instant ad hoc file drops over Wi-Fi. Use SSHFS Win to map your entire Linux hard drive as a native Z drive right inside Windows over Tailscale, and use Solid Explorer on your phone to natively browse your desktop folders via SFTP.
So, look at your own desk. Think about the mix of devices you use every single day. If your mouse has no borders, if your connections never drop thanks to those static Tailscale IPs, and if your machines instantly auto-connect the very second they wake up, what is stopping you from building your ultimate cross-platform ecosystem today? The tools are completely free, the blueprint is right here. I'd say it's time to take control of your battle station.